We're going to look at 7.2 on area of triangles. Now on the front page you'll see 3 different triangles. The idea with these is that the area formula for a triangle ends up being similar to the rectangle and parallelogram, but ends up being half of the size, because 2 triangles make up a rectangle. So this formula is over on the sideboard as you're working, and it's also on this paper, and it's right at the bottom of this page. Okay, so there's several examples, pictures of diagrams that have different heights and bases, but again, the triangle is half the size. So we're going to go to the back of the front page, and we're going to look at the examples on the back together. And again, you want to make sure, like with the rectangles and parallelograms, that you have base and height, and those base and height should be perpendicular to each other. So when I'm looking at question 1 right here, I have 9 for a base, and then I have that right angle, and then it gives me a dashed line with a 5, and that's going to be my height. So I know that I have the base and the height because those are perpendicular. So in my calculator, I would put 1/2 times the base times the height. And this is going to end up being 22.5, and then it's centimeters squared. Now with 2 and 3, I don't have, depending on how you look at it, I'll say I don't have the height for 2. There's no measurement. And for 3, I have 13 that's diagonal, but I don't have the height for 3 either. So what I'll have to do for 2 to find that area is I'm going to have to use sine, cosine, or tangent because there's a degree measurement. So I'm going to label each of these values. I got hypotenuse, I got 12 as the opposite, and then I got x as the adjacent. So based on the fact I have 12 and x for opposite and adjacent, I'm going to use tangent. So it would be tangent of 60 degrees equals 12 over x. So I'll put this over 1. We'll cross multiply it. So we got 12 times 1, which is 12. And then tangent of 60x. And then I want to divide both sides by the tangent of 60. So I'm going to pull up my calculator right now. And I'm going to put that into the calculator. I'm going to check first to make sure I'm in degree mode. So I got 12 divided by the tangent of 60. So that ends up giving me, and we'll round this to the nearest tenth, we'll do 6.9. So for my area, I have to do 1/2 times 6.9 times 12. So I'll throw that in the calculator. And I end up getting, for the area, and I'll put it up here near to the top, but you can fill it in on the area spot, 41.4 centimeters squared. So there's my answer for 2. And if you remember from 7.1, we actually did this problem. We had to use Pythagorean Theorem, and 13 is the hypotenuse, so it should be 5 squared plus x squared equals 13 squared. Square the 5 and the 13. Subtract 25 on both sides, you get 144, and then square root it, and you get x is 12. So for 3, the area is going to be 1/2 times 5 times 12, which ends up being 30 centimeters squared. Now, the ones on the bottom, I'm only going to do one of the ones in the bottom. So I'm going to take a look at B, because it's right in front of me right now. And if you have to determine the area from a grid, what you want to do is you want to create a rectangle that connects all the pieces or vertices in the triangle. And then what you want to do is just count the spaces up. 3, 4, 5, 6, 7, 8, 9. We have 10 spaces. And because it's 1/2, we got to take half of 10. So for B, the area would be 5. So I hope this was helpful. If you have any questions, just get my attention in class and I can come over and help you with any examples. Thanks.